video clip, you have already seen how to use this absolute or relative data entry to draft the required vector. Now, in case if you are totally new for this data entry, CAD data entry format, especially the polar data entry. So for those users who are totally new for this CAD drafting techniques, or probably the way you have not used AutoCAD or such CAD software earlier, for them, this further explanation will be very much what you can say useful. So for that, what I've done, I've just created one diagram, and this diagram which I've designed is showing the exact explanation about this polar direction method. What exactly is going to happen? Say for example, if I select the line tool and for now you can check out, I can change this color for my convenience even from the info box, not essentially I have to go inside the default setting dialog. So from here, if I just try to choose some color which will be, say maybe this green shade I'll be choosing, and if I'm going to place a new vector uh, for say the same particular 4500 distance. So just check out, if I pick a point, that pick point becomes my origin. So if this is the origin, okay, so you can check out right now if I touch with my mouse over here, then at the bottom x and y is showing some kind of a coordinates, like they are not exactly 0 0. So in case of relative method, what happened, once you select that particular location from where you want to begin, that becomes your temporary 0 0. So this becomes my now temporary 0 0. And what is the logic inside this polar direction method? See, for example, we are willing to draw this 4500 length vector, but do you want to construct that horizontal, or you want to construct that vertical, or maybe in some different direction? So that you have to specify, no? Because only the distance is not sufficient data to express your required vector to be get digitized or drawn in your CAD software. So for that, as the vector is nothing but combination of distance and direction. So 4500 is the direction distance we have already with us. But what about the direction? So there's a one possibility that you can see that from a pick point, if I go on the east side, that is on the right side. Okay, so if I go on the right side, that is the east side, that will be my direction to place the 4500 vector. Another possibility, I can go and try to, if I want to make it vertically up, then I can say north side, or I can go for a west side or south side. That means in four directions, I can travel very fluently by using these directions like east, west, north, south. Or maybe at the most, I can have additional four intervals like northwest, north, south, northwest and northeast, or southwest or southeast. So I can even try to maximum achieve eight directions in terms of this logic. But then it is not going to be sufficient, because if I want to draw a vector which is neither going for exactly east or northeast, it's in between anywhere. So how can I describe that? So probably you can have a little bit addition to that, that instead of calling east, let's call that as a 3 o'clock. Okay, so what will happen now? I have a much liberty, because I can have a 3 o'clock, or I can have a 12 o'clock, 9 o'clock, 6 o'clock, or in between directions, I can easily freeze. That is, you can actually describe your direction in terms of say hours, minutes, and second. For example, you are going to say that I want to travel towards 2 o'clock, or maybe 2 past 10 minutes and 20 seconds. something like that you can even try to add to give much flexibility in your, or accuracy, to add accuracy in your directions. But then what happened? Again, this is very critical to express that method of adding this 3 o'clock and 2 o'clock and everything is very critical, because apart from hours you have to add minutes and second. So that's not going to be that comfortable. So instead of that, what exactly the better solution was, what you can say, given, is to call that right side or east side or 3 o'clock direction as a 0 degree. Okay, so if you just check out, if I'm keeping my mouse towards this particular right side, you can see at the bottom where A is there, either it will be nearer to 360 or 0. Okay, so if I hold the shift key, it will be exactly 0, because that is nothing but constraint. No? The last time we have seen in the last clip how to constrain the mouse. So if I constrain my mouse, you can see now my direction is exactly 0 degree. Okay, so now onward I can start going up, and that is nothing but I'm traveling now anti-clockwise direction, and I'll call this as a 90. So again, if I hold the shift key, you can see my A shows exactly 90 degree. Okay, same way I can go and try to work on the west side, that is 180 degree, and bottom I'll say 270, and back to 0 or 360. But what is the beauty of this? That I can express my direction in terms of angle to any fine accuracy. Like, there is no restriction, like in which direction you would like to travel to locate your vector. Okay, so that's the reason this method was very much popular to work with, that is working with the polar direction method is a very expressive and simple method to work inside the CAD. So let's complete our that particular vector which we are supposed to complete. That is nothing but I'm going to, now this time what I'm going to do, just check out. If I'm either I have to type R, that is relative distance, that is 4500, and direction, that is angle, as a 0. So last time we have seen that if you just try to go for this combination of R and A, so you have to press R 4500, and then you have to go for A and 0. So either you do that, or otherwise you just hold the shift key and just try to use press R from the keyboard. You will see your angle is already locked now. That means you don't have to worry about typing the angle because it is already locked. Okay, so directly you can see now R is showing this data entry, and then I'll say 4500, and I'll just press the enter. So automatically my this horizontal vector was composed. So this is how you can obviously check with the measure tool. So if I just go exactly to the origin point, which is not going to be now 0, now it becomes a temporary 0, because always remember, now it becomes a 0 because it's a relative. And then if I touch to the end of the line, you will see that 4500.0 is the distance which I have marked. Okay, so this is the basic explanation for the polar directions. So using the polar directions is very, what you can say, beneficial or an easy method to express your vectors to be get digitized in any CAD software. So this logic is purely common in any CAD software. So you can use it in ArchiCAD, AutoCAD, Revit, or Vectorworks, and any other software which is actually compatible to accept the CAD information, that is computer aided designing. Okay, so CAD is nothing but computer aided designing. So in the next clip, we will start working using this polar direction data entry format, and for that we will see how easier we can do our this drafting method by using some additional helpers in ArchiCAD. Till then, you please practice this on this particular topic and earlier topics, so that it will become easier for you to proceed for the next clip. And now onward, make sure in every clip which you follow, at the end, in the description, if you read, either one lesson prior to that and one lesson next to that, links I will provide so you can have a what you can say consistency in traveling in the lessons or the clips in sequence.